Hello, everyone. I'm Adam Okada from Beyond Clean, and I'd like to express my gratitude for you choosing to spend your Friday with the speakers and myself. You are 100% making our day, and for that, we really want to thank you. I would also like to thank our event sponsor, 3M, for helping make this educational event possible. The title of this conference is Hot Topics in the Heat of Summer, and it has been such a great day filled with enlightening and engaging dialogue from our subject matter experts. Our next speaker is here to keep this day of education rolling. Mike Andersen is the Vice President of Marketing OR Products at Medline Industries. Mike has spent his professional career in the surgical instrument space. Throughout his roles, he has not only become very familiar with the care and handling of surgical instruments, but also an industry-leading expert on their production and the global supply chain of the market. Mike is here to finally answer the burning question every technician wants to know, which is, what is that rainbow-colored stain on surgical instrumentation? Could it be water issues, or is something amiss in the department? Mike is ready to debunk the mystery and expose the truth behind instrument staining prevention. You'll be glad you tuned into this session. I know I will be. So without further ado, let's welcome in Mike.
Adam, thank you very much, and I appreciate you all taking time out of your Friday, especially your Friday afternoon, maybe even later if you're on the East Coast, but taking time to sit in on the session. I hope it's informative for you guys. And we're going to go through a PowerPoint for about 30 minutes and open it up for some more Q&A because I'm sure there's going to be quite a few questions. If you tuned in this morning to Dan's presentation first thing, you'll notice there's going to be a lot of overlap here in terms of what he spoke about. I'll probably dive deeper into it in terms of things like passivation and hardening, which seem to be some of the questions that came up. So looking forward to this, and please feel free to reach out as you have questions. So the objectives today, understand how reusable instruments are manufactured and finished to really resist corrosion. We're going to discuss the root causes for staining and rusting. I want to explain to you too why true rusting is actually very uncommon, and oftentimes it's misdiagnosed, and we'll walk through how to diagnose that. And then ultimately, how do we reduce and eliminate the staining issues that we see on certain surgical instruments? As mentioned earlier, so when a surgical instrument's made, it comes from a forging. A forging is essentially this raw material you see on the far left. It's heated up, put under the pressure of a die that drops. It's a 3,000-4,000 pound die that drops down to kind of create that rough outline of the instrument, and that outline is trimmed so you can see kind of what's going to be kind of the basis of this. Looks like it's going to be a hemostat. Where the forging occurs is what they call substantial transformation, and that's what determines the country of origin. So you could have Italian steel forged in Germany. It's going to say made in Germany. Those finishing steps could and oftentimes do take place elsewhere for basic instruments, towel clamps, hemostats. It's a very hand labor intensive process, the polishing, the grinding. So this really is a global supply chain when it comes to surgical instruments. The good news is all these facilities that are making these instruments for all the U.S. suppliers that are selling reusable instruments, they all follow very strict ASTM and ISO and DIN standards for each manufacturing step. So it's really, you're getting a good instrument, I would say, regardless of the name on it. There's multiple competitors or multiple companies in the space, but they're all utilizing these contract manufacturers to make these things, and at the end of the day, a very good product is provided. I'm going to talk to you just a bit about the steel. The steel is ultimately very important. Depending on the application of the instrument or how it's used, you use 300 or 400 series steel. One is not necessarily better than the other. That's something oftentimes that I see or hear when I'm out in the field is, I want everything to be made of 400 series steel. Well, it's not possible because 300 is a much more malleable steel. So if you need a malleable instrument, something that's radio translucent, more malleable, or something that's a turned piece. So you look at things like middle ear instruments, anything that's turned and made on a lathe, that's oftentimes made out of 300 bar stock. It's a much more machinable steel. 400 is a harder steel, so you're going to see that being used in scissors, hemostats, clamps. 300 series, it's a softer steel. You'll see it in handheld retractors. It's a high nickel steel too. So what that does is, having high nickel and then high chromium content, that's really going to make it almost rust proof. You'll see certain implants, Steinman pins, K-wires, they're made of 300 series steel based on that high nickel content and the rust resistance it has. 400 series, is more susceptible to rusting. It does have a good chromium content, but there's also free iron and carbon in there, which is why some of these finishing steps are really important to making sure that you get a good long life out of the instrument. I've put a chart here to kind of show you, certain types of instruments and what type of steel that they're recommended to be made out of. And here on the right, these are 4 of the biggest forging houses in Germany. They provide probably 95% of the world's forgings for German-made instruments, and it's a pretty neat process what they do here with the tooling and the processes. But at the end of the day, they're giving you a very good pallet to work with, a nice piece of steel to manufacture the instrument. Heat treatment and electropolishing. These are really kind of the 2 biggest manufacturing factors into having a instrument that will last a long time, will resist everyday use. There's really 2 different ways or 2 different types of furnaces here. Earlier in the morning, Dan referenced kind of this vacuum furnace. That's the one on the left. That's an Ipsen. This is really kind of a market leading technology. Everything's computer controlled. It's documented. It's part of the lot history for the manufacturing of the instrument. And on the right here, we have it's a mesh belt furnace, and this is more of a conveyor system. So the advantages to this, when you're making things like kerosenes or microlaryngeal instruments, something that are long and skinny and flatter, what happens in the vacuum, they can kind of like a potato chip on you. They can kind of get some waves in it. So this mesh belt furnace system, which may look older, a bit more antiquated, still plays a very important part in the manufacturing of instruments to properly harden and keep the shape and form of some of these longer instruments. I mentioned hardness. So hardness is measured in what's a unit called Rockwell, and it's important to note that these hardnesses are called out in ISO and DIN standards. So certain instruments need to be hardened to a specific range, and not being hard enough will just create just a soft instrument. It won't hold its cutting edge. It's not going to last for years like it should. And then I often hear the question, well, can't you just really overly harden it so it's super hard? And the challenge with that is if you over harden a certain type of instrument or steel, it becomes brittle and it'll fracture. So it's really important to note that over hardening it's not a good thing. These are being hardened to a specific range based on years of manufacturing expertise, and those are being input into the standards. This was a kind of a hot topic earlier today. We talked about passivation. I'm going to take it a step further and discuss electropolishing. So passivation, if you were on the 8 o'clock call with Dan, ultimately passivation is the essence, the free irons being pulled from the instrument, the chromium content in there mixing with the oxygen, that creates this kind of passivation layer. Think about it as like a skin on the human body or an immune system. That's what's protecting the instrument from potentially corroding. It's done with a citric acid. It's safer to use. That citric acid, that basically kind of accelerates the passivation process. If you didn't use the citric acid passivation, that layer would form over time as it's exposed to oxygen, but that citric acid really kind of accelerates it. The electropolishing it's passivation with the same acid, but they're using electrical current in there as well. And what this really does is it takes all the burrs and ununiform surfaces off the instrument. Ideally, you want an instrument that has a very uniform flat surface. We'll discuss it a little bit later, but a lot of the staining and corrosion that you'll see in an instrument is really where it's created in a crevice, which is an area for water or contaminants or chlorides to really kind of get stuck into and burrow. So by having that flat, uniform surface, it really makes the instrument just last longer, and you'll see a much cleaner surface, on the instrument. And the passivation, I was speaking to some folks earlier. It used to be you would take a bunch of needle holders, you'd put them on this kind of wire jig, and you drop it into a bath of acid. It'd sit there for 35, 40 seconds. You'd pull it out, you'd move it over. They've really gotten to automating this whole cleaning and passivation. So you can see down here, this machine, this is often used around the world in leading manufacturing plants. It's not a cheap machine. It runs up to the tune of $750,000 to purchase. But what this does, this automates each step of the cleaning and passivation. So as I mentioned earlier, there is a standard that needs to be adhered to when doing this. And by having this automated machine, you can know that you have a repeatable and consistent process to achieve that desired thickness of the passivation layer of the instrument. All right, so stains and rust. I went ahead and I highlighted out all of the identifiable information on here. These are just instruments I've come across in my time in the field. You can see the ones up top, they don't look so good. That needle holder up top, you can see right there, and you can see where it's occurring is down in the serrations there. You have that orangish brownish stain. You can see the same stain occur in the box lock of the Alice to the right of it, and then on this knife handle here, not only in the serrations, but just on the surface in general. The good news is if you look at the bottom here, these were easily treatable. These were cleaned with just a soak and an acid rinse that's designed for instrument cleaning. They come out looking like new. That passivation layer continues to get built up. And what's important to note is that passivation layer continues to get stronger over time. Think about it like an immune system. It's going to continue to build up. So, oftentimes you'll see a phenomenon with you'll order a whole set of new instruments and, you get half of them that come out with a staining on there. And there's really a reason for it. And the good news is, depending on which instruments are staining, they likely are being made in 6 or 7 different manufacturing facilities, depending on what they are. So, for example, these knife handles here, there's one gentleman in Germany who just makes knife handles. That's his world. So if you see a knife handle and a delicate Castro both having staining issues, they're definitely made in different facilities, which really kind of leads you in the direction of, it may be an issue with water, chlorides, et cetera, that's causing this. And we'll get into a kind of a deep dive right now as to what causes that, how to identify it, and how to correct it. So a stain on the surface of an instrument, the old trusted way of really removing it and seeing if it's rust is the old pink pencil eraser. I carry multiple in my bag when I go out into the field. Usually an eraser, if it's just a surface stain, will easily remove that stain. The acid-based instrument cleaners as well as instrument wipes will all remove those stains. There's a crevice corrosion kind of phenomenon. So if you think about like down in the welded joint of an Andersen forcep, or in the serrations on the handle of an Andersen forcep, or in the box lock, areas where it's difficult to get RO or deionized water in there to rinse, that's kind of areas where the stuff gets trapped, whether it's hard water minerals, it's steam impurities, it's detergents. That's really where you'll see a lot of this. Oftentimes, too, it happens around the etching on the instrument, and I'll explain a little bit later why that happens. And as I mentioned, and we mentioned earlier in the call, earlier this morning, water and steam impurities. So regular water from whether it's coming from the municipality or wherever it may be, it has minerals in it, which is why we use RO water for the final rinse. But even softened water, so you have water coming in, you treat it to be soft. What do we use to soften water? We use salt, and salt's a chloride, which is probably the number one, culprit when it comes to creating pits and corrosions in instruments. Detergent residue, it can be on there. It may be the instrument is buried deep into a basket in the automated washer, and that RO or deionized final rinse is not getting down to those instruments. So there's stuff that's being left behind, and it may be a water spot, and it goes into the sterilizer, and it's exposed to the steam and the temperature, and all of a sudden it bakes on. You see this ugly stain, which is a cause for concern. So diagnosing these stains here. So I have a couple pictures, and I apologize. I tried getting as creative as I could with the text here and making the colors kind of associate with each type of stain. But so blue stains that you see, this is typically caused by the use of like a cold disinfecting or sterilant solution. Any type of like Cydex or things like that can potentially cause this. It can also be caused by sterilizing dissimilar metals, and I want to really touch on this because I think this is important. When I say dissimilar metals, this is stainless steel and titanium being sterilized together. This isn't 300 series and 400 series steel being sterilized together. That's not going to cause the issue. This galvanic plating phenomenon here is caused when you take two different types of metals, albeit stable metal, albeit being used to manufacture instruments for that we use today. That can ultimately cause this to happen. The biggest one that I see and hear about are the brown-orange stains, because it most closely resembles rust. It could very well be rust, and we'll get into how to identify that here shortly. But this is typically caused by minerals in the water or from detergent residue that's not being removed from the instrument. And as you can see in the case of this needle holder here in the bottom left, it typically builds up in areas that are hard to get exposure to. So, this is where you normally see it. It will normally come off. We'll explain here in the next slide what is ultimately how do you identify if the instrument should be continued to be used, or if you can clean it and move it along. And then probably the easiest one to fix are the kind of these white gray spots. This is similar to what you'd see maybe like at home if you have a dishwasher and you put like a Teflon pan in there, and you see these spots kind of on there. This is the same phenomenon with instruments. So it's the silicates that are in the supply water. These can be rubbed away with your thumb. They go away quickly. One of the best ways to prevent this is just to make sure the instruments are fully dry before they go into the sterilizer. I know in your departments you probably have lint-free cloths. A lot of you probably have forced air down there as well to dry these instruments. But the water residual on there, if you put it in the sterilizer, it's going to come out with these marks. These are not dangerous to the patient. It's more of an unsightly thing. So by really drying ahead of putting into the sterilizer, this will cut down. And then also having your water checked. You can work with whoever your manufacturer is of your automated washer. There's obviously a few companies out there that do that, but they can test your water. Another reference is the Red Book. The Red Book is a free publication. It was I was turned on to it by a few, in my opinion, very, very intelligent, well-read sterile processing managers, and I've read it. And it talks about the specific levels that you'll see in the water and really where you want to be. That'll also help you really kind of get dialed in what the water quality should be. All right, so we get to the point, okay, I think it's rust. What do I do? The old tried and true pink eraser, that will essentially remove some corrosion. What you may see beneath it, you can see this here in the bottom left, those are pits that are in the instrument. Can you guys see those little kind of dimples that are in the, this looks like maybe it's just the back end of like a DeBakey forceps. You can see these pits. That is literally a hole that has gone down beneath the surface. It's a cavity. When you see this, it should be taken out of service. This is truly an issue that will continue to cause rust to come up from the instrument. It's completely breached the passivation layer and got down to the surface of the metal. These are caused by chlorides. I'd say if you really want to see something rust and pit quickly, put it in saline. That will accelerate the process quickly. We actually use salt tests to determine how great the passivation layer is on an instrument, because salt will just degrade instruments. But other very common sources of chlorides are blood that are left on. So if you're not using a pre-soak, or maybe you have, this is just what I've seen, you have an L&D department that's on the other side of the hospital, maybe in a different tower, and those instruments tend to sit around a little bit longer until they make it back to your department. And as they sit there, if they're not properly treated with a pre-soak, that's when the kind of the degradation of the passivation layer really start to be seen. And I see it oftentimes like on the blades of Mayo scissors. It's where you see the pitting, and obviously your Mayo is your workhorse, so they could be using it for whatever it is. But and I'll touch base on this later. But the good news, pits are covered by warranty. It's part of the lifetime warranty. At least for the companies I've been with, I've worked with a few market leaders, and that's considered a material or manufacturing defect, and they will replace those. So if you do have instruments with pitting, or you have your local technician coming in to do repairs, make sure they pull those aside and you reach out to your local rep to make sure you get your warranty claim filed, and get yourself a new instrument. how do we prevent this? Really, the biggest thing here is that final rinse being RO or deionized water. In a perfect world, and I know it's not feasible, I'd use RO or deionized in every step just to prevent any of this. But that final rinse is critical. And then the way that you set up your sets in there, you think about, you get like an open heart tray, or you get like just a major ortho tray that comes in. It's covered, it's stacked up on top of each other. The things at the bottom typically don't get all the direct exposure to the deionized rinse. That can cause some of it, but just making sure that they are set up correctly. And then anything with a crevice, like an Andersen forceps, for example, if you can put it on its side versus laying it on one of the serrated surfaces, that'll help the water kind of pool off. You'll even see now in some of your more advanced, like orthopedic trays, where like lumen instruments, anything cannulated, they kind of put it in at an angle, which kind of accelerates the water leaving the instrument. That's really critical. It's just that pooling water is, whether there's detergent residue in it or there's minerals, that's what's causing a lot of this. I mentioned earlier using pre-soak in the OR. It's very, very important. This will help those chlorides in that blood from like binding to the instrument, and it's going to make it easier for you guys to clean. I always use the comparison, like my kids don't want like oatmeal or eggs in the morning, and I make it, and I'm rushing to get them off the door to get them on the bus, and I throw it in the sink and I forget about it, and I come back and I'm like, oh crap. So you're in there with the brush and the Dawn trying to scrub it off. That kind of stuff sticks to it. The same thing happens with blood and tissue. It likes to adhere to that instrument. The pre-soak will help slow that process. We mentioned earlier, make sure the instruments are completely dry prior to sterilizing. I know it does. I mean, to me at first when I thought about this, it seemed counterintuitive. It's like, okay, they go into the sterilizer wet, all that water is going to turn the steam base and the heat. But this is where we typically see kind of those unsightly water spots, is from the wet instruments going in. And then one thing that I don't see it practiced terribly often, and that could just be me not being home for the last 18 months, not being out in the departments, but lubrication of your instruments. So within your wash cycle, you have a lubrication cycle, correct? So it lubricates. It may not get in all the nooks and crannies of the instruments. Anything with a box lock, a sliding shaft, even a scissor, you can see in there, you'll see metal scoring where it almost looks like kind of scratches from the constant opening and closing. Those box locks, when they heat and cool in a sterilizer, they expand and contract. Sometimes they're going to be in a position where they create friction. Just using a milk bath and putting the instruments in there and actuating them will really make the instrument last a lot longer. It'll give you less of a chance to create enough friction in there where you're penetrating the surface, the passivation layer. And this is typically my number one trick to the kerosens that get binded up and they don't move, and you're squeezing them, you're pulling the handle, they don't work. A little bit of milk, put them in there, actuate them, they loosen up. Instrument milk is some of the best stuff out there, and will make life easier, for everybody, and also very much prolong the life of the instrument. Stains and rust. So what should I do when I see this? First off, don't panic. I've been involved with a few facilities that see it, and they decide we're going to go and overhaul our entire instrument inventory because of this. Really, we want to understand what's causing this before we start making hasteful decisions here. The vast majority of discoloration is easily treatable, doesn't pose a risk. This is just a matter of understanding your process, getting your water tested, working with either your equipment manufacturer or bringing in an independent company to test the water. It's pretty simple to do. And just know that there's a very small subset of manufacturers in the world that supply to U.S. companies. I'm obviously not going to name names or brand names in the U.S. market, but I've traveled the world. I've seen this for 18 years. I've been to Germany. I've been to Pakistan multiple times. Believe it or not, they do finish reusable surgical instruments there for some very, very reputable companies, things like towel clamps, hemostats, Andersens, and it's in very good, ISO certified facilities. But just know that this manufacturing happens all across the world: Malaysia, Indonesia, Poland, Hungary, Germany. But these companies are all very reputable. They've been around for a long time. Their documentation and paperwork is impeccable. And they're supplying all these U.S. companies. Most U.S. companies don't manufacture their own instruments. They're buying them from a contract manufacturer who's an expert at making surgical instruments. So it's not 99% of the time, it's usually not the instrument, unless it was just maybe it was a bad lot. And the good news is with the lot controls that they have, if we do see these things, we look at trends and history on quality complaints, and maybe it's tied back to one lot. Maybe something went awry, but there's documentation they can show to kind of assess that. So just know that it's not your entire portfolio of instruments you have that are causing the issue. Maybe it's one or two. If a pit exists, so you get there, and I saw a question that came up from Josh, and we'll address this here once I'm wrapping up here. This is my last slide. They're covered by warranty. So just like a cracked box lock, just like a jaw that snaps, this is a workmanship or material defect. Any reusable surgical instrument company should cover those and replace them as needed, because it is a function of the passivation layer breaking down and presenting you with an instrument that's no longer usable. So with that, that concludes the lecture part of the presentation. I know Adams, we're going to kind of get some questions that have come in that we'd like to address, so I will turn it back over to you.
All right, sounds good. Great presentation, by the way. Learned a lot about the staining and rusting and different colors and what they mean. So our audience is amazing. You guys are really incredible. We have a lot of questions that came in. We will try to get to all of them. If you do want to ask a question, you have an instrumentation expert at your fingertips. You are more than welcome to ask a question. Let me highlight that on your screen, the Ask a Question area, the Q&A section. Please feel free to ask the questions. We really do encourage it. I will try to ask them as they come in here. But let's go ahead and start with this one here in the Q&A. What causes titanium instruments to discolor?
So, great question. I love this. So, titanium by nature is gray. So if you were to go get a titanium instrument off the manufacturing line, it's gray. What color do we see titanium instruments in the market? They're all blue, correct?
Yeah.
Yes. So blue is just simply an aesthetic to identify that it is titanium. So what happens is that what titanium does is they take it through what's called an anodization process. So we spoke earlier about some coatings. You have like TiAlN, which is what you use for ceramic, but titanium is easy to anodize. It will only anodize to about 4 or 5 colors. It's not nearly as anodizable, that's a word, as aluminum, which you see like your basket, your lids, your containers. Those are aluminum, so you see so many different colors. But what happens is that anodization that's on there will begin to wear away in the presence of more aggressive chemistry. So if you're using a detergent that's maybe like a 10 pH and it's not getting properly neutralized or rinsed, you'll start to see that blue kind of fade away, just like you would with a lid for a sterilization container after repeated use.
Awesome. Very good. So let's see. Polishing an instrument. Does polishing the instrument create a pacification layer?
So there's 2 different types of polishing. So you have what you're traditionally your hand polishing. If you look at single-use instruments, oftentimes you notice they have that really high mirror finish, and that idea is to help prevent it from rusting. But those single-use instruments do not go through the passivation process. So hand polishing does not create the passivation. The accelerated passivation is done in the presence of a citric acid, which really accelerates kind of that chromium oxide layer to be created around the instrument.
Okay, gotcha.
The polishing is really to make the surface smooth. So that's why we talked about electropolishing. Not only is the passivation layer being created, but that electropolishing technology is making the surface smooth. So you're taking out defects, burrs, and giving it a uniform surface.
Okay, I gotcha. And I kind of have like a follow-up or a little bit to do with that. So the instrument finishes, does that have anything to do with the staining? Does a mirror finish or a matte finish, we have all these different types of finishes. Does that have anything to do with the staining at all?
It's like driving a black or a white car, after it rains. certain cars show stains differently. It can happen, right? So a matte or a satin finish will typically show more staining, especially when it comes to water spots, than a mirror finish. And I think it's more of a visual thing than actual presence of that the cause of the discoloration. But yeah, visually they those ones will jump out more than others.
Okay, great, perfect. Here we have another one. Can pits be ground out and a new layer of pacification put on?
I guess technically yes, it could, depending on how deep it is. But I wouldn't trust anybody to do that, like in a repair van or a repair facility. I would ultimately go back to the original equipment manufacturer and request the replacement via warranty. Based on the cost, the chance that pit may be too deep, there may be structural or integrity damages to the instrument. I wouldn't recommend doing that.
Okay, excellent. What is the best way to prevent rusting? This says a lot of our instruments are older and rusting is occurring quite often. What do you feel like is the best way to reduce? I know you had that slide in there, but what's the best thing, the number one thing they can do?
It's all about following the IFU and making sure that and when I say water, it's every step of the way, whether it's tap water using in your wash basins, the steam, all those things, that exposure to blood, maybe after a procedure, the quicker you can reprocess them, the better. Use pre-soak. Chlorides, it's just salt, and they exist everywhere. That's really kind of the root cause. What I would do though is I would make sure that is it truly rusting? I go back kind of to that kind of test that I showed you. You typically don't see older instruments rust as much. I shouldn't say discolor or rust. Where you see it mostly is like kind of the new instruments right out of the package, where that layer is still building up, and you'll see like what we call kind of surface corrosion, where it doesn't necessarily go down and make a pit in there, but like you're seeing a reaction on the surface there, where maybe it cut into the passivation layer a little bit. That can be wiped away, and that passivation layer rebuilds like you would like if you had a cut on your skin. But if it's an older instrument, and whoever asked that question, if you want, you can reach out to me directly via my contact information. I'm happy to even come out to your facility. We could take a look at it, and I can hopefully help diagnose what's causing that. We could find a solution.
Yeah, absolutely. And then I'll probably, I don't know if you know the answer to this one, but I'll take this one if you don't. How often should you change your DI or RO tanks when in use?
I by no means claim to be a water quality expert. Adam, I know your background here. Maybe you could better answer this question. So yeah, please, if you don't mind.
Yeah, no problem. So it depends on the type of system that you have, and how often it gets replaced, how often it's getting used, how big the tank is. So there's no real solid answer. I know in one facility that I worked in, we did have them come in monthly to replace the filters, and the tanks itself were getting replaced. Some facilities I've seen it at a week. So it just depends the size of the unit, what type of unit it is. Is it DI, RO, whatever? Remember, RO is a semi-permeable membrane. It's not a filter necessarily. It's not really a system like that. So it's a membrane the water filters through that creates that RO. DI is a completely different process. Distilled is, when it heats to steam, and then it's the residual water that comes out of that that's more purified than the regular water. So it just depends on your system, and then how often I would say go to your water manufacturer, whoever is the one that actually supplies the tank, and ask them how often those things should be replaced. But here's a good one for you, Mike. How does wiping the containers with alcohol affect the metal?
It depends on how the container's finished. Alcohol and stainless steel is okay. On aluminum, it could affect the anodization. Not knowing which container you're referring to, or if it's just a standard like gray container versus the colored lids, I would contact the container manufacturer. But it shouldn't have an impact more than it may just dull the anodization layer. It's not going to necessarily, destroy it.
Okay. Very good. I got a follow-up question on the DIRO thing. So they changed the whole tank every month. Yes, it was a smaller facility. We had I don't know what to say, about a 6-foot tank that they would bring in every month, and they would take out the old one, and that was what our water quality company did. They would just replace that every month. So yeah, and it was new to me too. I've never seen that. I was more used to like RO systems where they had the whole membrane thing, and they would come in to change filters, and they would do things like that, but they wouldn't actually change the tank. So that was new to me too. Let's see. What role do vendors play in assisting sterile processing departments with instrument maintenance?
So, I mean, I would say a good instrumentation rep, should be able to come in and help diagnose issues when they do occur. They should be there when the repair bin comes back from, I guess, the instruments that are beyond repair. And they should be in there and helping file the necessary paperwork to have the warranty replacements sent in. I will say that you'll see, just based on kind of the length or the amount of time in the position, you have certain reps that know this stuff inside and out. They've been doing it their entire life. They have crazy dreams every night about why something's back ordered. That's not me personally, but there's guys that have been doing it for guys and gals that have been doing it for a long time. They can certainly help you. There may be some less tenured reps that don't have the answers, but ultimately they should be able to find you those answers. There's a support team internally of engineers and product specialists that should be able to get that information to you. But at a minimum, being able to provide IFUs, being able to explain the IFU, why it's why it is the way that it is. If you're having issues with wet packs, they should be able to help understand why that may be occurring. This is just speaking from my experience.
Yeah, no, that's perfect answer. That's great. And with the issue with that, one of our listeners was having about having water quality issues and a lot of staining on their instrumentation. A couple of months, or actually it was about a month ago, Beyond Clean had an event where we actually had a water quality expert on, and they were talking about the staining that occurs on instruments. Basically, any type of staining is not a natural occurrence. There's something going on with the water or the solutions, or as Mike was saying earlier, mixing of the metals. Something is happening to create that stain that is not a natural process. So if you are having a lot of it staining instrumentation, probably the number one thing you want to look at is your water quality and your chemistries. Is the water quality good, and is it affecting the chemistries? Possibly pH balance, all those kinds of things. So water quality, probably the number one thing to look for with staining on instrumentation.
It's always an outside source. For 99% of the time, it's an outside source is causing that.
Yeah.
Instruments just don't bleed and stain.
Exactly. Yeah. And there was, I worked at a facility where we were getting brand new instrumentation. We would take that instrumentation, take it to decontam. We'd manually wash it and then put it through the automated washer. And when it came through the washer, we noticed that it had brown staining on it. And it was brand new, never been used in a case. It could not have been a bioburden thing. It could not have been rust, but it was definitely stained, like a brown stain when it came out. And again, that's when you test for water quality, because there's something is happening that's causing those things to go bad.
That's my least favorite phone call that I get, because it's so for the end user, it's so frustrating, right? You just spend all this money on brand new instruments, and typically you need to get them up into service quickly because it's for a new service or a doctor, or maybe there's more procedures coming on board, and you run into that and you're like, oh my gosh, what do I do? So I can understand the angst that comes from that.
Yeah. But that's why we do educational seminars like this, is, other people are having those same issues. I know that I did. So it's definitely good to get this information out there and get you guys some answers that you can actually take back to departments and actually make some changes in departments. This has kind of to do with the similar question to the container question earlier, but is the use of alcohol-based disinfectants bad for instrument integrity?
I wouldn't say that it's bad. I'm always kind of I'm always curious. Maybe Adam, maybe you can enlighten me on this as well, because I'm not a sterile processing manager or expert when it comes to that. But I don't necessarily know why that would be used if you're going through an automated washer with a thermal disinfectant. Ultimately, the instruments would be safe to handle because they've been exposed to a temperature that makes them not terminally sterile, but they're disinfected. So depending on the alcohol mix you're using, usually it's just like a germicide that's designed to kill, it's like used for surface treatment to kill TB, MRSA, et cetera. I don't see it used terribly often in instruments because I guess maybe it's just more for safe handling for the technicians as they're assembling the trays. But I would think, or I know, coming out of that thermal disinfector, that they are safe to handle based on the temperature and exposure that they have.
Yeah. And I think, primarily, I think where a lot of these questions may come from is that if you're at a smaller facility, I know that I've been at smaller facilities that didn't actually have a cart washer. Yeah. And if you don't have a cart washer, you have to wipe down the carts and disinfect them somehow so that they're safe to handle. And I think there's where we see some, is this approved for instrumentation? You do have to check your IFUs. Is this approved for use on the surface that I'm using it on? And that applies to stainless steel, aluminum, all these things that we see in the department.
I would say scientifically speaking, and it is in IFUs that I've read, at least some, they do have the call out for using alcohol. Alcohol is not it's not caustic or corrosive like chloride. So I think you'd be okay. But I do get it. I oftentimes forget there are facilities, maybe even smaller clinics, right, that are reprocessing products, right then and there, where that's an important, piece of the process.
Yeah. And then with alcohol, alcohol is such a strange disinfectant anyway, because it requires 5 minutes of wet contact time. And that's the recommended amount of time. It has to stay wet with the alcohol. Most facilities can't keep that up because the alcohol is meant to dry really quickly. As soon as it's exposed to oxygen, the alcohol will dry up. So it has to have 5 minutes of wet contact time. And, I don't know how you're getting that, but unless you're really soaking it in alcohol, then, I don't know what it does to the metal. So I think that's maybe where these questions are coming from.
That's how you treat swimmer's ear, right? Like, your kids have swimmer's ear, you put the alcohol, the drops in there and it dries it out. Yeah, that's...
there you go. Yeah. What type of protective coatings can we apply to instruments during the manufacturing to discourage biofilm buildup? Do you know anything about the biofilm buildup on instruments and coatings they can use?
So I can talk about coatings because I know the coatings pretty well. In terms of the building up of biofilms, I think Dan mentioned it this morning that he was working on something to prevent that. But as far as I know, and I would have to go back and check, but things like what we call ceramic, it's not actually ceramic, it's titanium aluminum nitride. It's a compound that's basically baked on in an oven. That's going to really protect the instrument from corrosion, make it a nice smooth action instrument. It is technically harder, so if it's on a cutting surface, it'll make it a little bit harder, but the first time you sharpen that, you take that coating off, you're back down to the stainless steel. I don't have any information to where I could confidently say that it's protecting against biofilms. That's something I'd have to make a note of and do a little bit of research on.
Yeah, and I think Dan did mention something this morning about those antimicrobial nano coatings, things like that. A lot of things that they're working on, and I know that's a lot of it that's in the experimental phase and things like that. But really, I think Beyond Clean did another seminar recently about that too, where we were talking about different coatings and what's going to happen in the future to those, and antimicrobial coatings. I think definitely something you're going to see on surfaces first, probably on workstations, decontamination sinks, things like that, and then maybe it actually will be able to move. That technology can move on to instrumentation as well. So exciting stuff.
I'll tell you what. It's interesting you bring up coating. So for all of you here that you've handled supercut scissors, and they used to use, or maybe even the old McCullough retractor, it was covered in black chrome to kind of give it that dark black finish. Black chrome now is basically eliminated from the European Union. So on your supercut scissors now, instead of having those black chrome dipped handles, they will be using that titanium aluminum nitride, which is a much more stable coating to put on there, albeit it's more expensive. But I think as they continue to look at which coatings that they're going to be using, and I mentioned the EU because the majority of the stuff is made in Tuttlingen, and some other Eastern European countries, but I'm sure these are things that they're going to be looking at as they, try to figure out what coatings are going to be, safe for long-term use and hopefully something comes of it. That'd be a very innovative thing for instruments.
Yes, absolutely would be. When creating an IFU for an instrument, how important is it for the manufacturer to have a firm understanding of water quality and chemistry used to clean and sterilize the instruments?
So I would tell you when an IFU is created, and I think most of the folks here, if you attend ISHM conferences, you know that like High Power Labs does a lot of the testing. Nelson Laboratories does a lot of the testing to validate these IFUs. You know, they're testing in perfect conditions. They have all of the everything dialed in correctly. So when you send out an instrument, you know, let's say we have a worst case scenario that we're using for an IFU. Typically, it's something that's very like small and long lumened, because that's the most challenging from a kill perspective in a sterilizer. But you know, we're in a position where these labs are using perfect conditions, or actually everything that they should be doing to create these. So the IFU is designed to provide a consistent outcome on the instrument with those conditions being in place. So we couldn't necessarily say, okay, we're going to do this one with no RO water in the final rinse, because it doesn't really put us in the direction we want to be put in, where like we're recommending this. So I guess we can't really take into consideration not having all those conditions in place when we put the IFU together. Does that answer the question?
Oh yeah, definitely. I mean, the manufacturers have to take all those things into consideration, right? Of, you know, what are the users going to have on hand? You know, what are the water quality issues, and then try to replicate them in the testing and make sure that. Yeah,
and the testing's based off of standards as well, right? Yeah. So like ST79, ST77 is a containment device, but 79, like these are things that, okay, we're saying we need to do these. This is what we're going to test it to.
Yeah, absolutely. All right, so if you guys want to keep asking questions, keep those questions coming. I think there's 16 in the Q&A. That's awesome. Keep those questions coming. I'll highlight that area for you, the Q&A section or ask a question section on your screen. What do you recommend for staining on instrumentation that cannot be removed? Do they get sent out for repair, or is it time to replace them if that stain will not come out?
I would give it to your on-site instrument repair technician. Maybe it's something that just needs a little bit more elbow grease, and they have polishing and grinding wheels on their trucks that could potentially take it out. If it is a very stubborn stain, I'd recommend filing a warranty claim with your instrument manufacturer and having them replace it.
Excellent. Very good. If an instrument is stained, not rusted, not pitted, is it okay for reprocessing and use on a patient?
I would recommend removing the stain. I say that because it could very likely just be some residual hard water. I don't think it would necessarily pose a risk, but I think it's a multitude of things. Not knowing what it is, maybe a risk does exist. You also sometimes will have an unhappy surgeon or scrub tech when they see that stain on the instrument. I would do everything you can to have that removed. And if it's just a quick soak and everybody sells this stuff. It comes in a gallon. You pour it in cold water. You soak it for 15 minutes. Use a soft bristle brush as stain comes out. But I think I would err on the side of caution. Make sure you send things up that are clean. With that being said, I've been in enough surgeries. I've seen enough sets of instruments that are really, really beyond where they should be in terms of just kind of having those stains taken off, and surgeons still use those. But those stains don't necessarily. They're not containing any type of microorganisms that are going to, potentially lead to infection if they are truly a stain. Now, if it's blood that's left behind, right, and that sometimes can be difficult to identify, then that kind of material is a challenge, and ultimately you can't sterilize organic material. So, I think it's best practice to have that stain removed.
Yes, absolutely. I mean, then you kind of hit the nail on the head right there. Which is, if you can't identify the stain, how would you feel having that used on you? How would you feel having that instrument used on a loved one, right? I mean, if you can't identify it, my guess would be take it out. I mean, that would be my recommendation too. I mean, just get it out of the set and try to see if it can be removed on the truck, or maybe there's something that the instrument manufacturer can identify But yeah, I would definitely not want those kinds of things used on me or on anybody I love. If the water is testing normally and the instruments are still rusting, what would be the underlying cause?
I would say it probably ultimately comes down to the automated washing cycle with the arms in there. So it goes back to kind of that configuration. You typically see for any of these advanced items, they come in trays that put everything in a nice order, and they're in brackets and set up correctly. It's when you dump an ortho major tray into a basket and you've got stuff on the bottom, it's just not getting that the exposure to that the high pressure RO final rinse, and that's where you're typically seeing the staining. So, and I know it's challenging, right, to have everything kind of in a single layer, not having instruments set in a position where they can cool. Anything with a concave surface that is left sitting vertical, like typically water pools in there, and if it's not rinsed correctly, that's where you see it. I would definitely look at the load configuration as you put it through the automated washer.
Yeah, definitely. Where is that water contact? Because we know it's something to do with a liquid that's penetrating, right? We know it's like if you were to soak it in saline, that's going to really eat away at the passivation layer. Yeah. It's going to eat down into the surface of the steel. There's going to be pitting. So really trying to examine where could that be happening.
And even if you're using, let's say you're using just regular softened tap water for just the manual decontamination of the instrument, you have the chemistry there. If that's not rinsed off thoroughly with the RO water and that final rinse, that's where you're going to see and potentially see challenges. And that's the last 18 months, my kitchen's turned into kind of an R&D SPD lab, because I'll get stuff sent to me and I try. My wife doesn't like it very much. I got a utility sink that I use, but you start to, that's the kind of stuff where you look at, okay, where was this actually sitting in a tray? And it's like, oh yeah, this was an Andersen forceps that was sitting beneath a chest spreader. Like, did nothing, no water got to it, and it goes to the sterilizer and stuff, it cakes on.
Yeah, absolutely. So examine your process, look at places. I mean, remember that proteins coagulate at about 140 degrees Fahrenheit. Yeah. So if you are not cleaning the instruments properly and then you put them in the automated washer where it's going to get really, really hot, it may not be able to get through like biofilm that is formed. And then you're just coagulating those proteins, and that could be a source of rust. We know that blood and bioburden, underneath those, we see rusting and we see pitting. So it could be a cleaning process. Like Mike said, it could be definitely a detergent or a chemistry issue. So even though water quality may be testing okay, there may be other things going on in the process that are causing that.
And as chlorides are heated, they become much higher. The pH level becomes much higher. So, the pH, the higher pH was really causing the red and orange stains. The acid is what's kind of neutralizing that. So there's a multitude of factors, and that's a great point you bring up, Adam. That the thermal properties of these processes too have an impact.
Yeah, they can definitely. Is there anything you should not use to remove the stain or rust?
Yes, I could probably think of things. Wire brushes, while they're great,
That was the first thing I thought of too. Yeah,
will score the surface. Use a nice nylon bristled brush. Even like the reamer brushes that we have are nylon bristled to get like bone chips and things out of there. But I would start with the safe stuff. And when I say eraser, get like the nice big, the big pink pencil eraser, not the one on the back of a pencil. That'll really help. Like I mentioned, use a commercially available instrument cleaning solution, which is typically acid based. They're available from everybody. Anybody that sells detergents would typically have this, but I wouldn't go to like the Home Depot to try and find something. The steels that are being used in these items here, they're not typically used in other commercial applications. So I would start there. As I mentioned, if there's an issue, myself, my team, we have people that travel the country that help with this. We're certainly willing to at least provide our opinion on what can be done.
Yeah. And instrument companies, like he was saying, detergent companies do have these stain removers. They're designed for surgical instruments to remove those stains. I would say instead of anything you shouldn't use, that's really the only thing you should be using is those stain removers to remove those stains. I haven't told this story in a long time, but I was one of the first facilities I worked at. They had a little Brillo pad, a little stainless steel Brillo pad. And anytime there was a discoloration or rust, they would be scraping it with the Brillo pad. They're like, oh, it comes out nice and shiny. And I was like, yeah, you're completely destroying the instrument as you're doing that.
That's like using using steel wool for your really nice, like, things you cook in, right? You take that coating right off. So,
that coating comes right. Like if you did it with cookware or anything, you would take the coating directly off, and then now you've got rusting even worse. And they were wondering, why do we have so many rusty instruments? And I was like, well, that right there is probably a big reason. What do you think, if I'm going to have to put you on the spot and I'm going to say, what is the number one thing that you think is the most common thing causing instrument staining? What do you think it is?
I would say mineral retention on the instrument. So whether it's a mineral from the water, it's from the detergent, look and see where these stains occur. They're typically always in crevices and serrations, and then those will spread, right? So you'll see it on a flat surface. That's typically from the water circulating and then kind of spreading that to some of these other flat surfaces. But I don't see rust very often. It's 1 or 2% of what I see. The majority of it is and there's charts. Like I keep mentioning the Red Book. I just like it because it's very independent. The people that wrote it, it's a conglomeration of industry folks from all over that they've all put together. They have a similar interest in educating, and it walks you through just kind of the differences between like tap water, softened water, and RO water, like how much of a difference that can make when it comes to discoloration of instruments.
Yeah, very cool. That would be very helpful to have that kind of chart there. What can be used when an instrument is rusty and needed that same day?
I'd go through that process quickly of the eraser, see if it can be removed. The cool soak, the acid soak's about a 15-minute process. It comes out. It should rub right off. If that stain cannot be removed, I would recommend not putting it in the service just to make sure that it's not truly rust. Those first 2 steps will typically address any type of surface stain, but the eraser and the soak usually will do the trick.
Yeah. And those soaks, I mean, like we talked about it, they're from every detergent manufacturer, every equipment manufacturer. Just about everybody has some form of stain remover. So just whoever does your instrument supply, go to them, ask for some type of stain or rust remover. And a lot of, like you said, a lot of them are, 10, 15-minute soaks. And, it shouldn't add a ton of time. So even if it's needed that day, you should be able to incorporate that in your decontamination process. It really is like magic. It kind of eats away the rust and kind of pulls it all away and leaves it nice and shiny afterwards.
It's an acid-based solution. So you think about how passivation occurs. That's a citric acid with oxygen bringing that chromium layer out. So it's really doing the same thing. It's cleaning and it's strengthening the passivation layer. Your pH detergent. So 7 is considered neutral. Most people will use like a 10 because it's a little more aggressive, and when you combine it with your local water source, it just does a better job cleaning, but it can also have that detrimental effect. The good news is you have that acid, which is like a 2 or a 3 pH, and it'll essentially clean it off.
Yeah. And don't leave it in there overnight. I've done that before. I've seen an instrument left overnight. It will destroy it because it is an acid base. So eventually the acidic will get down.
Eventually the acid will win.
Yeah. So make sure you set a timer and make sure you pull it out when it's time, because it will like you said, strengthen that passivation layer. It'll make it nice and shiny. It'll take away the rust. It's like works like magic, really. But don't leave it in there. Make sure you take it out when you can. We got a couple of questions on that Red Book you mentioned. Can you elaborate on that, what that Red Book is and where people can get a copy of it?
Is there any way I can share a link here? Am I allowed to, may I post? Into the Q&A?
Yeah, put it in. Yeah, let's see. I'm not sure. I know there is a way that you can kind of share things here. Maybe Brett on the back end can figure out a way that we can get that to him. But for now, can you kind of explain how they can find it?
Yeah. So if you just Google I just literally Googled Red Book Surgical Instrumentation. And it's on the second link down. It's from the MMM group. It's literally a free 92-page book. If Gary Bassey's still on, I know he presented before I did. Gary and I have over dinner have gone through this thing extensively, and it's just like I mentioned, it's not one company trying to push their agenda. It's a conglomeration of Ecolab, 3M, Storks, all these water, like everybody just getting together to like put like a really good publication out there to help really.
Absolutely. So can you put that in the Q&A? If you can put in the Q&A, then Brett can post it.
I just
to the attendees.
Okay, I just put it in the team chat. Maybe I screwed that up, but
let me see if I can do that.
Maybe Brett, you can see it there. Q&A. Here's my Q&A.
Brett did it. He got it. He got to it before me.
All right,
Darn it,
there
Brett.
we go.
You're just faster than I am.
All right, he's quicker on the trigger there, huh?
Yeah. All right, so that's the link on the screen there.
Thanks, Noel, for sharing that as well.
Yeah, absolutely. Yeah, for those that are familiar with it, that MMM group, the Red Book there is the publication. So you can see that on your screen. We are kind of out of time, Mike, but incredible job, incredible information. I think everybody got a lot out of it. Thank you again to the attendees. You guys had so many incredible questions come in. I apologize if we weren't able to get to any, but Mike, just amazing job, critical insights on such a highly important topic. You can connect with Mike via email or LinkedIn. I'll go ahead and highlight his speaker bio there. So feel free to reach out to him if you have any further questions we weren't able to get to. As a reminder, we do have a short 15-minute break here. We're glad you're here. We'll see you back in 15 minutes. Bye, everybody.
Thank you.